Bismillahirrahmanirrahim. So first of all, welcome all of you for this special lecture about three-phase power system. Now what is a phase? Remember, phase I discussed before with you that phase is a pair of conductor. Yes, pair of conductor. So if I say single phase, so it will be one pair of conductor. So in conductor there will be one with a voltage and one without voltage, which is treated as a ground or as a neutral. So when I say three phase, so there will okay. So when I say three phase, so there will be three conductors at least, with the fourth one as a neutral or as a ground. So if I say phase, as I told you, there will be with the voltage, there will be one with the ground, or it will be known as a neutral. Similarly, when I say three phase, so there will be three conductors with the voltage, and the fourth is optional depending on the connections, from where the power is coming. So when I say fourth conductor, so this will not have any voltage, but it will be either grounded or it will be known as a neutral conductor. Now, how you generate this single phase, it is already single phase. But in case of three phase generation, these voltages, it should be in proper magnitude, proper frequency, and proper phase angle between the voltages. Now that voltages in generator, what we do in generator, the generator stator I will say, because here we rotate the rotor in case of generator, and there is a stator 330 you have discussed already. Now this generator will have the three windings to generate one voltage, to generate the second voltage, and to generate the third voltage, V1, V2 and V3. Now these three voltages should be in proper phase angle. Now what we do, we have to divide this three phases in this from zero angle up to here is total 360 degrees circle. Now when I divide this 360 degrees into three equal parts, it will be equal to 120 degrees. So if I say that this conductor A and this is A dash, we put the conductor winding from here and take it from the other end, one conductor or one winding, one coil. Yes, so this will be one. With respect to this one, I will put another winding which should start at 120 degrees from this angle. This is 0, 0. So at 120 from here, if I start, it will take, this is 90. So it will start from here. So B will start from here, and B dash, it will be on the opposite end. Okay, opposite end. Number third. Now the third winding, again I should take 120 degrees from here and start at a position. So this is 0, this is 120, so this is 180. If I say it will be 240 somewhere here. So there will be C and the other end of the winding, which is like this winding. This is C, this is C dash. So it will be enter from here and it will come out from here. Now A dash is one winding producing one voltage. B dash is producing another voltage, and C dash is producing a third voltage. Now if I generate the voltages from this A, this B and this C, yes, so I will get this A, this B and this C, these terminals. Yes, this number fourth one, A dash, B dash and C dash, I will join them together to get the neutral point in case the generator is connected in Y connection. Y connection, for example, not like this. If I draw it similar to this one, not to confuse you. This is A dash, this is B dash, and this is C dash. 120 degree apart or no? Yes. So now if I join them, this A dash, B dash and C dash together. So this point is known as a neutral point in case of Y connected generator. If I connect it like this, A dash, yes, then B dash, and then C dash, winding in proper sequence, yes, A dash, B dash and C dash. So what I will do, I will join these two and I will take one line. I will join these 2 points and I will take another line. And I will join these two and I will take the third line. So here there is one line, V1 voltage, V2 voltage and V3 voltage. Now, now in both cases you get here 3 conductors. Here you get either 3, or if you need you can take another one as a neutral conductor, which is this one. Now why we call this as a neutral conductor, I will explain it after some time. But right now, just say that this point is a neutral point. Neutral means 0 voltage. 0 voltage, yes? Now the question is, when I told you there is a phase, so phase is between line and neutral, yes? So here there are 3 phases, line and neutral, line and neutral, line and neutral. So this is a phase, yes? But there is another term which is known as line voltage, line voltage. So line voltage is nothing but between one line and another line, between one line and the second line, and between the third and the first one, yes? So there will be 3 voltages. It will be V, for example, in this case I will say VAN, VBN, VCN is phase voltages. Phase voltages. VAB, VBC, VCA, between A and B, between B and C, between C and A. As I told you before, it will be line voltages. Yes, between 2 lines it is line. Between line and a neutral it is phase voltage. Yes. Now what is the relationship between line and phase? Because here this voltage is different, line and neutral. Yes, this is different. This is the voltage between here, between here, between here. It will be the same. Yes, because there is two things. One is balanced voltages, and the other is unbalanced. When it is balanced voltages, so the voltage between A and N, B and N, and C and N, they will be the same. But when it is unbalanced, so maybe this voltage will have one magnitude, this will have another magnitude, this will have third magnitude in case of phase. In case of line also, AB, BC and CA, they will have different numbers, different magnitudes. Now, as I told you, the magnitudes of this, I will start with phase voltages. Then I will calculate the line voltage, and then I will give you the equations for that. What is the relationship between this and this? Yes. Now what I will do, I will first ask you that if I say that the magnitude of this voltage is A voltage with angle, how much? 0. So if I say VAN, it is equal to V angle will be 0 in polar form. Polar form, like this. VBN, as I will consider this one, unbalanced I will not consider. Yes, unbalanced we will not consider now. Okay. We will consider only the balanced voltages. Now, when it is balanced, so the magnitude is the same. Magnitude is the same, but the angle for B is 120 degrees. Now, if it is like this, it will be minus. If it is like this, it will be plus. So 120 degrees. Similarly, VCN, it will be equal to V angle minus 120 degrees. Yes, magnitudes are the same, but the angles, they are displaced from one another by an angle of 120 degrees. Now, if I ask you to draw this wave shapes, so it is easy. Yes, for example, if I say that the frequency for this voltage F, it is equal to 60 hertz, all voltages. Yes, all voltages, frequency is 60 hertz. What I will do, I will draw this like this is time and this is the magnitude, time. Yes, so what I will do, first magnitude, it is maximum voltage or RMS value. It will start from zero angle. It will continue like this and it will reach to complete the cycle. Yes, complete the cycle in certain time. Now the second one, it will be plus 120 and this one is minus 120. So the second one, it will be displaced from the first one by an angle of 120 degrees. So it will be, the second will start from here. This is 180. Divide this into three parts. So it is 60, 120, 180. Again 60, 120 and 180. So the second one will start from here, complete it like this, and it will continue like the second and the third. Okay. Now how the second equation, it will start from minus 120. It will start from here. Yes, R, it will start from 240. Yes or no? 240. So what we will do, this third one, it will start from here. Yes, if you continue, go back, so it will go like from here, it will go like this, and it will come like. Similarly, if you come like here, yes, so you can see, you can draw it according to the magnitude and according to this one. So if you see all the three curves will be separated from one another by an angle of 120 degrees. It's not according to the scale, so you will find it. But if you draw it in MATLAB, or if you get from the generator Meyer the original waveform, so you will get the waveforms like this. Yes, all the three displaced from one another by an angle of 120, 120 and 120 with respect to one another. Now if I ask you that okay, this is minus and this is plus VB. Yes, this one is 0, this is minus 120 and this is plus 120. Okay, now if you want to write this in time domain, so maybe you have already studied this conversion, how you write this. If I ask you in time domain, so it will be VA is a function of t, and there will be V maximum sine omega t plus or minus theta degrees, and this theta is this angle. Plus is for positive and minus is for negative. The magnitude, it will be the same, whatever the magnitude. Now conversion from RMS and maximum you already know or not know? RMS to maximum, yes, divided by root 2. V RMS is equal to V maximum divided by square root 2. Already, that is the conversion from the maximum value to this the value. Now, how you will find, why the question is, I told you this point is a neutral point. neutral point. If you agree with me on these three numbers, voltage angle 0, voltage angle minus 120, voltage angle plus 120. So if you agree with me on these three equations, so just means what I will do, I will draw them according to this graph. What is this? If this is A dash, this voltage, A dash, yes, then there is B dash. So if I add here B and B dash, yes, and then there is C and C dash. So if I add them together, this is A, C dash. So if I add them together, this plus this plus this, the net vector is how much? 0 from the vector addition. Yes, or if you do not understand like this, so I will say V at n, it will be equal to VAN plus VBN plus VCN. If I add them together, it will be equal to V angle 0 plus V angle minus 120 plus V angle plus 120. Just means put the values in AN, BN and CN and solve them, convert them, add, subtract real and imaginary with one another. So here you will get V. Yes. Here convert this into a rectangular form. Rectangular form. So what you will do, you will get 0.5 V cosine minus 120 plus J sine minus 120. Yes, here also plus V into cosine 120 plus J sine 120. So when you add here, you will get here V, here you will get minus 0.5 V. Yes, here sine 1, this one, it will be equal to minus 0.5 or 0.86 root 3 over 2V minus root 3 over 2V. Yes, okay. Similarly over here, V into cosine 120 plus J sine 120, if you add here, it will be minus 0.5 V plus J, yes, root 3 by 2V or what 0.5, whatever. Sine, calculate this number. Calculate this number. So if you see over here, this V minus and minus plus, so this one will cancel with this one. You will get here 0 real number. And this imaginary and this imaginary will cancel with one another. So you will get J0. What does this mean? That if you add this vector voltage with this voltage with this voltage, you will get the net voltage at the neutral point will be equal to 0. Yes? Therefore, this point is known as a neutral point. This point is known as a neutral point. One more thing, always the generators are connected in Y connection. Sometimes special generators are connected in delta. But most of the cases we connect it in Y connection. Yes? Now if that is the condition, you will have a phase voltage and you will have line voltage. You will have a phase voltage and you will have a line voltage. What is the relationship between the line voltage and the phase voltage? I will explain that. What is the relationship between the line and the phase voltage? I will explain that to you, and then you will 50% of the objective of this course will be over. Yes, because that is the most difficult part. Now in that case, what I will do, I will draw this lecture, here. This is voltage A dash, B dash and C dash. I connected them together and make it as a neutral point. as a neutral point. Yes, this A dash, I take this A dash. B dash is this B dash, and C dash is the third terminal of the winding, third winding. So I connected them as a neutral. Now, if this is the phase voltage, this is another phase voltage, this is the third phase voltage. So the voltage between this and this, it will be known as line. Voltage between this and this, it will be known as line. Voltage between this and this will be known as line voltage. But how you will calculate that line voltage? For this, you have to consider the internal structure of the generator. Now the internal structure of the generator, as I showed you over here, there will be three windings. It will be one, I will draw like this. One winding, A dash, there is another winding, B and B dash, and there is a third winding, C dash. Now the function of generator is to supply the current as a source. So when current will go like this as a source, so here this will be minus, this end will become plus because there is a source generator. Yes, here it will be minus, this will be plus. This will be minus, this will be plus. The current will go like this, because it will supply, yes, as a battery. Because always what you do whenever you represent the generator, you represent it like this, minus and plus. Okay, Varada? This is not the drop, it is the source. Yes, minus to plus, because the current will flow from minus to plus, and then it will make some voltage drop, and you calculate the voltage drop. And so if this is the condition, you will calculate, I will remove some part. Now look over here. A and N, B and N, and C and N together. A and N, B and N, C and N in the phase voltages. Now you have to calculate the line voltages. Now how you calculate the line voltage? It will be, for example, I will give you one example. For example, how I will calculate the voltage between A and B. So it will be this one. So if I have to calculate the voltage between this one, so it will be equal to VBA, voltage from B to A. Yes, this is, for example, this is you say minus, this is plus, it goes like this. Goes like this. So this is minus, this is plus. Okay. Voltage rise, AN or BN, it is equal to, yes. It is equal to, this voltage rise is equal to drop, VAN. And this one, rise. So rise will come here, VBN. Okay, rise plus rise is equal to drop. So this is rise, this is drop. When you calculate this loop, take the loop. Okay, Valada? So in this case, you know the VAN and VBN. What is unknown? VA. So you will calculate VBA. It will be equal to VAN minus VBN. Minus VBN. Equation tells you. I do not tell. Yes? Minus plus, minus plus, minus plus. And from B to A again I say it is minus plus. So if you apply the Kirchhoff voltage law, so voltage rise is equal to drop, and this is again voltage rise. So put it on one side and the other side, you will get the equation. Now if you see over here, if you see in this equation, VBA, it is equal to this and addition of the second vector, addition of the two vectors, yes, AN and BN. So, but what you will do, it is actually equal to A plus minus VBN. You will add these two vectors and you will get VBA. Huh? Now, how you will add them? For example, I say this A and N is this one. A and N is this one. B and N is this one. So where it will be minus VBN? In the opposite side, because this is plus VB. Minus VB, it will be in the opposite direction. So if I say that this is VA, N, VBN is here, but minus VBN, it will go in the minus VBN. Yes? Now what I will do, I will add this vector with this vector like this. Like this. So what I will do, parallel to this one, I will draw one parallel line. Parallel to this one, I will draw another parallel line. This is VC. VC, the third vector. Yes. Now the resultant of this is minus VBN. When I add this with this one, when I add this with this one, so how I will add? By head to tail rule, I will get this VBA or VAB voltage. Now the question is, the magnitude is not equal to this one, not equal, yes, not equal to this one, this magnitude, and the angle is also not 0, not 120. What is the angle? You have to find that. Yes. Now if you see over here, if you see in these calculations, the calculations are simple. This angle is 120. This angle is 120. So when this is 120 and this is 120, equal. So when it goes in this direction, it is 120. When it will go back, so it will divide this angle into half. So this angle will become equal to 60 degrees. 60 degrees. What will happen to the parallelogram diagonal? What it do? The diagonal of the parallelogram divide this 60 degree again into half, and you will get here 30 degrees. 30 degrees. Okay. Now one thing is known, that when you calculate VAB, when you want to calculate the voltage VAB or VBA, the angle is not 120, the angle is not 0, the angle is not 60, but the angle will be 30 degrees. Angle will be 30 degrees. With respect to what? With respect to VAN. VAN. But the magnitude of VAB, it is not equal to VAN. It is different. Now how you will find? It will be divided, means find by the rule, divide this into two parts again. Two parts. So this angle is 90. This angle is, if this is 60, this is 90, this will be 30 degrees.
This will 30?
30? This is 30. Yes. Yeah, this will be 60. This will be 30. This will be 60.
Yes.
Okay. Similarly, over here also, this will be 90. 90. This will be 30. This will be 60 degrees. Okay. Now, what you want to find? You want to find this total length. Total length. Now, total length, if you find this x for this triangle, similarly, there will be another x. So, VAB, it will be equal to 2 times x. 2 times this x plus this x, it is equal to 2 times x. Yes? Now, what is x? How you will find x? How you will find x? Just means apply this trigonometry to find the base. to find the base. So, yes, so it will be equal to, x will be equal to EAN into cosine of 30 degrees base within 90. So what you will do, when you put the values over here, it will be equal to EAN into cosine of 30 is root 3 by 2. Yes, take this value, put it in this equation. Take this value, put it in this equation. So it will be equal to 2 times EAN into root 3 by 2. So this 2 will cancel with this 2, and VAB, it will be equal to root 3 times EAN. EAN. So this VAN, not E, I will say V. V. Here also V. Yes, V. Now this VAB, it is equal to root 3 times VAN. So here I will not put V, but I will put root 3 times. So the relationship between the line voltage and the phase voltage is now the root 3 multiplied, and the angle is plus 30 degrees. Plus 30 degrees with respect to the phase voltage. If similar to this one, if I want to find VBC, yes, so it will be equal to root 3 times VAN or BN or CN, any value, because the magnitudes are the same. Voltage into an angle here, here it is plus 30 degrees, so here it will be, the resultant, it will be like this. Because the angle between this resultant and this resultant should be equal to 120 degrees. Should be equal to 120. Here, these two. Yes, because the second triangle, it will be made like this. Yes, the third one, the angle between this and the next, it should be again 120 degrees, so you will get another magnitude like here. Another magnitude you will get over there. So what you will do, it will be equal to, yes, here it will be equal to 130, this angle will be equal to plus 120, plus 120, 150, not 120, 150, plus 30 degrees, here. And the third angle over here, if you come like this, it will be 90 degrees, minus 90 degrees. Or if you come like this, it will be 270 degrees. Understand or no? Okay. So just means remember that if you want to calculate the line values, it will be multiplied by root 3, multiplied by the phase angle, and angle is whatever the angle you get plus 30 degrees with that. Plus 30 degrees. Now if you see over here, if you find this VAN, VBN, VCN like this values, and I ask you to calculate the line voltages, so this V, this V, this V, same. What I will do, I will say VAB, it will be equal between A and B. It will be equal to root 3 times V and angle 0 plus 30 degrees. Plus 30 degrees. VBC, BC, it will be this angle plus 30 degrees. So it will become 90. Yes, minus 90. Here it will be 120 plus 30 degrees, so it will become 150 degrees. Okay. Now if, understand or no? Okay, number one. Number two things, second thing, this was the story about the voltages. If I ask you the currents in case of Y connection. So this generator will supply the current. This generator will supply the current. This phase will supply the current. Now what you will do when this supply the current, what it will do, you will connect this to the load by some line. Yes or no? Here you will connect, for example, the load is connected like here. I will clean this some. What you will do, there is a generator, minus, plus, there is this, and it is connected with certain load. This is this phase, for example. Okay? It is connected by a line to certain load, and then there is a neutral. There is another this winding, and there is another load between this line and the neutral. There is a third line, yes, and you connect the third load over here, not here, between here and the neutral line. Between the line and the neutral. Now the question is, this is phase voltage or a line voltage?
This is the
Phase. Here also it is phase voltage, and here also it is phase voltage. To the load and load. Now, if I ask you how much current is flowing over here and how much current is coming over here? Same. Yes or no? This current and this current is the same. This current and this current is the same current flowing in the line. Okay, Walala? Now this line current, but the voltage over here, this is phase voltage or line voltage? Phase. Huh? So the phase voltage and phase current, it is the same thing. Yes, phase current is the same thing. Phase voltage and phase current, it is same phase current flowing in this phase, it is equal to this current. Same current flowing in this phase is equal to this current. Now what is this? This is line 1, this is line 2, this one, line 2, this is line 3. So in case of Y connection, I phase, it is equal to I line. This phase current, yes or no?
Yes.
Is coming in this line, and it will be the line current, same current. Here also it is this, but the voltages, the phase voltage and phase voltage, the voltage between these two lines is not the same, voltage. So what is that voltage? V line, it is equal to root 3 times V phase, and angle is theta plus 30 degrees. Plus 30 degrees. Phase plus whatever the angle. For phase A, it will be 0. For phase B, it will be 120, either plus or minus. Or phase C, again, it will be depending on the phase. So these two equations are for Y connections. For Y connection. Yes? Now come, there is one more thing in this Y connection. One more thing. There is a term which is known as a sequence. Sequence. Malum walala? What is sequence? Sequence is either A, B, C sequence or opposite C. So in electrical, in your book, there are two. One is known as positive sequence and one is known as negative sequence in 3-phase system. Now what is positive sequence? Positive sequence is the sequence when they are arranged such that if you have, for example, 3-phase system, this is A, this is B, this is C. This is A, this is B, this is C. Okay? Like as I draw over there. Now, what will be a positive sequence? What will be the negative sequence? Just I am telling you that one. Now, if you stand here, Huh? Stand here and rotate these phases A. Yes, rotate this like this. Huh? So first, which phase will pass by you? A, then B, then C. So if you rotate this like this, so first you will see A, then you will see B, then you will see C. Yes, A, then B, then C. If I change this arrangement such that here I put A, here I put B, C. Here I put A, here I put B, here I put C. Possibility. Winding A is here, winding B is here, and winding C is here. I designed the generator like this. So in that case, again, if I stand here and rotate this again like counterclockwise, not clockwise, counterclockwise. So it will be A, then there will be C, there will be B. Now what is this A, B, C? This is positive sequence. What is this A, C, B? This is negative sequence. Also, whenever I say negative sequence, so I will be meaning like this. When I say positive sequence, so I mean this is like this. Okay? A, B, C.
If it wasn't a negative sequence, you rotate
The same.
so it's not like
Always.
clockwise, but
Always counterclockwise.
just the random.
Yes.
That means it depends on the design.
Always, this for the internationally recognized standard that always do the sequence is determined by this method. Yes, always determined by this method. So phase A, phase B, and phase C. This will be
phase A, phase C, phase B.
yes. This will be ABC sequence. If it is like this, it will be ACB sequence. Now
Because
this
how ACB and we will take it as a counterclockwise.
always counterclockwise. Motion up. This, for example, this is A,
Okay.
and there is the second one. This is A, this is B, and here the third one is C.
Yes, C.
Yes. So if you move like this, so first A will come, then C will come, and then
Okay.
B will come.
Yes.
Rotate it.
Yes.
Starting from which one will cross your body.
Yes.
Yes. So just means
Advantages of the sequence.
no advantages, but just means sometimes depending on the design of the generator. In this sequence, because you do not know, you will buy one generator from one place, another generator from another place, and they will make this voltages such that, yes, here it will be written C, but the angle will be plus 120 degrees. Here it will be written B, plus 120 degree, minus 1, and here it will be opposite. So when you connect the system, one power plant with another power plant, so this sequence will be important. Otherwise, if you join this B with this B with this B, so the magnitudes are the same or different? If you join this B with this B, different. Magnitudes will be different. Angles will be different. So there will be spark, blast. Yes. So it is not like easy to. So you have to make always in power system maybe 340. Students who studied with me before, I give you that there are 4 conditions to satisfy before interconnection, and those 4 conditions are same voltage, same frequency, same phase angle, and same sequence. Yes. So if any one of these 4 is not satisfied, you cannot connect the system. Voltage, frequency, phase angle, and sequence, all 4. Any one of this not satisfied, khalas, no problem. Yes, but this is one thing. Another thing is, if I calculated this, all this I phase, I line, B, L and root 3 plus theta degrees for which sequence A, B and C. Yes or no? This is minus B, B, N. So this is A, this is B, this is C. I calculated this. Huh?
Yes.
Now if I say that this is positive sequence, so I get this answer. Huh? When it is negative sequence, what you will get? When it is negative sequence, how you will get? What, the same answer or no? So the answer is no. We will not get this. This you will get, but the angle, it will not be plus 30 degrees, but it will be minus 30 degrees. Why? Why? Minus 30 degrees. Anyone? Huh?
To see what it comes.
Yes, no, but equation, it is the same equation what I did here. But here I am saying it is plus 30 degrees in case of positive sequence. In case of negative sequence, where it will start? It will be A, this is C, this is B. What is the equation? V, A, N, B, A, it is equal to A, N minus
B.
B, N. The minus B, N will be where?
And the negative side, this one. Yes.
Down. Yes? So when I find the resultant of these two,
We should add minus
yes,
30.
yes. So it will be, this will be the resultant. This will be the resultant. Huh? So here, instead of plus 130 degrees, for the negative sequence, it will be minus 30 degrees. So when
So
this,
it will also be minus,
Huh?
minus 120.
yes, here it will be this minus 30 degrees. Here again it will be the second one, and here it will be 90 degrees. Understand? So in both cases you will add here plus 30 degrees with the original phase voltages and minus 30 degrees with the original phase voltages in case of negative sequence. The currents, it is the same for phase and line in both cases. Currents are the same in both line and phase value. Okay? Huh? Now, now you have understand any question up till now? Because I will remove this and I will start with some calculations and other things. Any question up till now? Huh? This is the final conclusion. Huh? For Y connection, I phase is equal to I line. And the second one, V line, it is equal to root 3 times V phase angle theta plus 30 degrees for positive sequence and minus 30 degrees for negative sequence. This is the final conclusion for Y connection only. For delta, I will do it now. But before going to delta connection of the generator or the load, yes, I will give you one example just to tell you how you calculate the phase and the line calculations, voltages and currents. For example, if you see there is a generator, there is another generator, there is third winding of the generator. This is A, this is B, this is C. A, B and C. And it is connected by a transmission line with a Y-connected load. Y-connected load means the load is Y and the generator is also Y. So what I will do, I will connect with the load. There will be A, yes, there will be B, there will be C. But this is A, this is B, this is C. What I will do, I will connect again A with A, B with B, and C with C to keep the same sequence. So what I will do, here I will connect, this is A, I connect it with A. B, I will connect with B. And C, I will connect with, this is C. And I will connect this B over here. Like this. Okay? So, the sequence in both cases, it is the same. Yes? Now, the question tells you that this angle, it is 120 angle 0. 120 angle 0. And the voltage over here, 120 angle theta 2, and this is 120 angle theta 3. Here theta 1 is 0. Theta 1 is 0. Okay? Now, first of all, tell me what is the sequence of this generator? Positive. Why? Because if you stand here, first B will come, then C will come, then A will come. Yes? Or if you stand here, yes, first A will come, then B will come, then C will come. So the sequence is positive. And I told you that in case when the sequence is positive, the angle it is B, A, and neutral. Between this, it is given to you 120 angle 0, given to you. This is minus, this is plus, this is minus, this is plus, this is minus, plus, just to give you the polarity that it is a voltage or battery or a source. Yes? So V, B, N is what? 120, same magnitude, but the angle will be, in case of positive sequence, minus 120 degrees. Positive sequence. And VCN, it will be equal to 120 degrees plus 120 or minus 240. Both same, no difference. Or this is minus 120 or plus 240. Yes, both are the same thing. This number one thing is finished. You have calculated theta 2 and theta 3. Now the question is, what will be the line voltages? What will be the line voltage and what will be the third line voltage? So you can easily calculate that. How you will find? V line, the answer is root 3 times V angle theta plus 30 degrees. Why plus?
Because
Positive sequence. When it is negative, I will put here minus. Yes? Now, if you want to calculate the line voltage, it will be equal to root 3 times 120, angle is 0 plus 30 degrees. It will be equal to 208, angle 30 degrees. 208 angle 30 degrees. Okay.
VIB.
Yeah, VAB. Between AB. Now, if I ask you that there is, the load is connected as like this, and the magnitude of this load, it is equal to 3 plus 4j. Here also it is 3 plus 4j. Here also 3 plus 4j. Complex numbers. Yes. So how you will find the phase current and how you will find the line current? Yes. So what I will do, if I join this neutral with the neutral, because this voltage is known. Voltage is known. Yes or no? Yes. So if you join this neutral with the neutral, so there is one simple method. This you have done, calculated, simple. Line voltage is equal to root 3 times V phase voltage. Okay, Valada?
Yes.
Now, if you want to calculate the line current and the phase current, for the time being, for the time being, this is the line current. This is the line current. This is the phase current in this load. And this is the phase current in the generator. Both are same or la?
Yes.
All are the same. Now to solve this, this is a neutral point. Voltage is 0, voltage is 0. The voltage between this point and this point, it is the same or different? Same. Yes, same. When it is same, so just means how you will find the current? I, it is equal to V over Z for this phase, for the one phase. Now V, it is known 120 angle 0, and Z is 3 plus 4J. Z is 3 plus 4J for this phase. So it will be equal to, I will say A and N, between small a and small n. This is capital A and capital N. Capital A, capital N. So just means put this number, solve it, you will get the answer which is equal to 24 angle minus 53.1. 53.1 degrees. Yes. Now this IAN is known to you now. How you will find IBN? How you will find ICN? So if you know this voltage, if you know this voltage, if you can find the other currents also. Already you have known. Malum wala la? Yes. So you can find the second phase currents. If I ask you the line current, it is the same as Corner equation. Okay, Valada? So don't afraid from the question, just try to see what is he asking. Line, wala phase, wala angle, or what? Huh? So just
the line voltage for where? Here in the circuit.
this line voltage, it will be between this point and this point. A and B. Yes, between B and C, it will be magnitude will be the same, but angle will be different. Yes, C and N, C and A, it will be between this and this.
Yes.
Yeah. Okay. Okay. Yes.
Phase current will be equal
Equal, yeah.
in each phase.
Each phase angle will be different.
Yes. In the Y connection.
A Y connection. Yes, but phase current and line current, they will be the same. Okay.
We add 120 to minus.
For what? The current? IB, and yeah, just need this one. This angle voltage is malum, known to you. So it will be IBN. It will be equal to VBN divided by Z. What is VBN? It is this one. Yes or no? 120 angle minus 120 divided by 3 plus 4J, this impedance. It will give you again 24 angle some number.
Minus phase current, right?
Huh? Phase current. But this phase current is the same as line current. Okay? Huh? This phase current will be equal to, so you can calculate this one. Now if I reverse the case, I connect the load as a delta. Not the Y load, not Y load, delta load. So in delta, what we see, just look over here, Look over here. This is one line coming over here. Yes. There is another line coming. There is a third line coming. So I will draw over here. This is one line. This is the second line. This is the third line coming. And I will connect now a delta load. Yes. So what I will do, I can connect it like this. This is one load. Yes. There is another load. There is a third load. Yes or no? All connected in such a way, or you can say that this I will keep it open. I will keep it open. Yes? Now for example, this is A, this is A dash, this is B, this is B dash, this is C, this is C dash. Now what I will do, the current flowing in this load, for example, it goes like this. Yes? In this one it goes like this, in this it goes like this. So this current, it will be equal to IA, this will be equal to IB, this will be equal to IC, or CC dash. Yeah? Now what I will do, if I supply it from the generator, some current will come. When it reach here to this common point between C and A, like this common point. Between A and B, common point is like this. Okay? Between B and C, common point is like this. When it reach here, it will go some like this and some current will come. But always, in a delta, the current will circulate in one loop. It will always circulate in a loop. Yes, it will not be like this, that some current will go like this, some will go like this. Up to you. Whether you put it like this or you put it like this, up to you. But it will, if you put it like this will come, then it will come, then it will come. If you do the reverse, so then if you say like this, then it will come like this, then it will go like this. All it will give you the same answer. Yes? Understand?
Yes.
But it will always circulate in the delta or in the loop. Okay? This is number one. Number two, here I will say that the current is equal to I from capital A to small a, capital B to small b, capital C to small c. It is like this, this is, I will say I, B, B. Okay, and here I will say I, C, C. If I say that this end is A, this end is B, and this end is C. Okay, small c, not. So the capital N from the generator, it is meeting with A, B, and C. Now, if you see over here, if I connect the generator over here in Y, A with A, B with B, and C with C in delta connection. Now this current over here, it is, this phase is equal to this line. This phase is equal to this line. But this line is not equal to this phase. Same or no?
Yes.
No. This phase current is equal to this line current. But this line, it is not equal to these two. Over here also the same, not the same. Now what you will do, you have to find the relationship between, this is simple. For Y it is simple, this rule. But for delta, the line and the phase current has certain relationship. Now what is that? We will discuss that. But in case of voltages, this is phase voltage. This is phase voltage. This is line voltage. Now, up till here, line voltage. Here it is line voltage. And between these two, it is line voltage up till here. But when you supply it to the load in delta, yes, so this A and B, this small point, this is a phase or a line? Phase for delta, yes. delta. This one and this one, it is a phase or line? Phase. This one, this load is a phase or line? But the voltage over here will be equal to the voltage over here. Understand or no? The voltage in this phase over here will be equal to the
This
voltage, line voltage. The voltage over this phase will be equal to the voltage in this line. So in case of delta,
the second, the first or the second?
this one, this phase, whatever phase it is,
Yes.
whatever phase it is, this, the voltage over here is a phase voltage, but this phase voltage will be equal to this line
This,
voltage.
yes.
Okay, this is a phase voltage here
Equal to
for the
B
load,
and C.
for
Yes.
the load. Yes, but when you want to measure this one for the generator, it will be the line voltage.
Yes.
Understand? So for delta connected load, this is for Y. For Y connection. For delta connection load, V line will be equal to V phase. Whatever the line voltage, you will get the same phase
Same
voltage. No change in angle, nothing will be there, just as in Y connection. Yes? Now come to the currents. Current. For example, I say to you that this current is IA, this current is IB, this current is IC. Huh? This one. Now what you will do? How you will measure this? What is the relationship? This is phase current or a line current? Phase. This one? Line. Phase or a line? Phase. Line. Phase and line. Now there is some relationship between them. How you will measure? For example, if you want to see this one, so apply Kirchhoff current law at this node. Kirchhoff current law at this node, because current is coming, current is coming, current is going out. But this will complete a loop.
Yes.
This current is out. So just apply Kirchhoff current law at that node.
At each node and you
At each node. Yes. Now here if you see IAA current into the node plus IA is equal to IC. Yes. So IAA will be equal to IC minus IA. Understand or no? Now if I draw here the voltage curves, if I draw it current curve, you will get the same root 30 degrees, 60 degrees, 30 degrees, and then this one. So here you will get root 3 times I phase current and angle theta plus 30 degrees for positive and minus 30 degrees for negative. Understand? Rest the method is the same what I draw for voltages. Triangles and this 30 degrees and root 3, everything it is the same. But instead of voltages, I will draw the currents. So you will calculate the what? Current. Okay. Now if I summarize up till now, if I summarize what we have discussed up till now, it will be this table. This is Y connection, this is delta connection. There is a voltage and there is a current. Now in case of Y connection, I line current is equal to I phase current. Yes, one, and the voltage V line voltage is equal to root 3 times V phase. This is the basic. At least you should know this thing. Yes. If you want to go do further research, there is another angle. There will be theta plus 30 degrees for positive sequence and minus 30 degrees for negative sequence, as I told you over here.
Yes.
This is number 1. Number 2, in case of delta connection, either in generator or in load, both cases. Yes.
V load will be equal
V
to
line,
V phase.
it will be V line, not
sorry,
load.
yes, yes.
V phase, number 1. Yes. But I line, as I told you over here, yes, it will be equal to root 3 times I phase current and angle theta plus minus 30 degrees for the positive and negative sequence. So this is the conclusion up till now.
This is the delta as a load
Generator also same.
generator also.
Generator also the same, because here if I connect it as a generator, there is one winding, there is another winding, there is third winding, and it is supplying the current. Yes or no?
Yes.
So the current will not flow here or here or here. It will always circulate in a loop. Yes, so if you do like this, so the current will come like this, current will go, and current will go like this in this loop. This is phase current or line current?
Phase.
Phase. This one?
Phase.
Phase. This current? Apply Kirchhoff current law. So you will get the same voltage in terms of currents.
Inside this loop, phase current is equal.
Yeah, always it will be balanced condition, it will be the same. Unbalanced, it will be different. Angles will not be 120 in case of unbalanced. Yes, unbalanced, the angles will not be the same and magnitudes will not be the same. Different. But in case of balanced, the angle will be 120 and the voltages will be, currents will be same or different.
And what?
Currents and voltages will be same or different. Balanced. Same. Okay. So like that. Now there is questions in your book. If you read that book by yourself, because the just multiplication and putting the numbers. I will go to the three-phase power now. No need. Power. Need or no need? Need. Yeah. Clear. Just remember this thing. It will help you in your calculations. This table. How this comes, I explained it to you.
There's no neutral line.
Yeah, in delta there will be no neutral line.
Where the current goes?
The current usually, the current will come back, consume here, this one, so no neutral over there. What we do in that case, we put the neutral over here. Force. In this future course 441 and 340 and some other courses, you will find different types of generators over there. Some generators it will be Y connected, some generators it will be Y connected with the neutral grounded, sometimes you will get it grounded through a reactance, sometimes you will find this ground through a resistance depending on, so the current it will come because it will consume here and it will come finally and go to the ground. Go to the ground. Yes, so in your course now, this y and y delta is only considered. Delta generator and delta it is there, but it is not included in your course. But if you want, same theory is applied for that also. Yes?
Which course this one?
In your course, whatever the course you study. Yes, maybe 201, it is 2 only. But later on, higher courses, 400 and 300 and like that, it can be YY, it can be Y delta, it can be delta and Y, and it can be delta and delta. 4 arrangements can be there. But the theory, it is the same theory, no change. Line voltage is equal to what? Phase voltage is equal to what? Phase current is what? Line current is what? Basic is this one. Yes. Now let me give you maybe 15-20 minutes for power. I will use the same equations. Yes. in case of power, whether it is a generator or it is a load, in both cases, the equations will be the same. One will be power supplied, one will be power consumed. Yes, power supplied and power consumed. Now, how you will calculate the power in case of three phase? So, if it is a, for example, Y connected system, either generator or a load. I will put the general, general. So if it is a generator, it will supply the power. If it is a load, it will consume the power. But it is a three phase. So what we will do to make it simple now, the power, the total power consumed or the total power supplied by this generator or the load, it will be equal to this power plus this power plus this power. Yes or no? This is a phase or a line? Phase. This one? Phase. This one? Phase. So all the three phase power, it will be equal to P1 plus P2 plus P3. Yes or no? What is P1? It is equal to V into I into cosine theta. What is V? It will be V1, it will be I1. So it will be P1. Yes or no? What will be P2? It will be equal to V2, I2 cosine theta between these two. Yes? And P3, it will be equal to V3, I3 cosine theta 3. But I told you that the voltages and currents, voltages magnitudes will be the same. Huh? Same. Balanced. Currents magnitude for balanced load, it will be the same. If it is unbalanced, this will be one power, this will be second, this will be third. Add them together, you will get the total power. But in case of balanced, this voltage, and this voltage will be the same. This current, and this current will be the same balanced condition. Power factor, same angle difference. Yes? Between the voltages and currents. So cosine theta, and theta will be the same. Now total power, it is equal to this plus this plus this. It will be equal to 3 times V into I into cosine theta. But which V? Line voltage or phase voltage? Phase voltage. Current. Line current or phase current?
No difference.
Huh?
Same.
Huh? Phase or line? Yes? Here. So I will say a phase current. Okay? Now, if I say total power in case of three phase, it will be equal to 3 times total power. V phase into I phase into cosine theta. Yes? But if you want to convert this phase value into the line values, so what is the relationship between this in Y connection, for example? Y connection. Y.
Just the root 3.
Yes, V line, it is equal to root 3 times V phase. Yes or no?
Yes.
Root 3 times V phase. But here I have V phase. So how I will write V phase in terms of V line? It will be equal to V line over root 3. And what is I line and I phase relation?
Same.
It is the same. So I line. So what is the, simplify this now. Simplify. What I will do? Multiply and divide by root 3. So what will cancel? 3 and 3 will cancel, and you will get root 3 VL IL into cosine theta. Yes, so what is the conclusion? The conclusion is, if you are using the phase values, you should put 3 here. If you are using the line values, you should multiply by root 3. From where it is coming? From the same equation it is coming, using this basic table. Now the second thing, if it is a delta, you say that there is a delta generator, a delta load. delta generator or delta load. So the power over here, and power over here, it will be added together to get the total power. Huh? Okay, Valala? Hmm? So in this case, whatever the current is flowing here, multiplied by the voltage here. Current multiplied by the voltage. Current multiplied by the voltage into cosine theta. Yes? Voltage. Now, what is this voltage? It is no, the voltage in case of three phase over here. It will be the phase voltage here in this one. Yes, later on we will see it, because the current is phase, so the voltage will also be the phase. Here also the voltage is the phase, the current will also be the phase. Here also this one. Now if you want to calculate the power generated by this delta generator or power consumed by this generator, power consumed by this load, delta connected load, the equation will be the same equation. V into I into cosine theta, this will be in 1. Here again. So total power PT, it will be equal to 3 times V into I into cosine theta. Which phase? I will say V phase, I phase. Phase voltage, phase current, phase voltage, phase current, phase voltage, phase current. Now if I want to convert this into line values, so I will use this delta table. Delta table. What is line and phase relationship? Same. So I will put here 3 and this is V line. And what is the relationship between IL and IP? It is IL over root 3 into cosine of theta. So just simplify this again. You will get here root 3 times VL IL into cosine theta. So it is the same equation. Yes, so you can calculate the power. Similarly, if you ask any question,
Can we take a rest for
just means I think 5 minutes more I will take and then finish.
the battery will
Just means 5 minutes I will take more and then I will finish. So, understand?
Yes.
Huh? Balance. Unbalanced, no.
What about the imaginary?
Yeah, I'm coming to that. This is for P. Yes? For Q, everything is the same. Only here you will put sine theta. Sine theta. Instead of cosine. Here it will be Q1 will be equal to, because here it is P, this is Q, and this is S. S, complex power. Now how you find Q? It is equal to V into I into sine theta. Here also sine theta. Here also sine theta. Total S, total Q, it will be equal to 3 V phase, I phase, sine theta. Put the line and phase value, you will get the root 3 times VL sine theta. Like this. For S also, S it will be equal to V into I. Khalas. Without angle. Here also, V into I. Now to calculate the total, it will be equal to 3 times V into I. Convert it into line, so you will get root 3 VLIL. Okay, well. So just means this is S and Q. Now if you want to calculate do you know power factor?
Yes.
Power factor. Power factor means this is active power, this is reactive power, this is complex power. Yes, the angle between these two is known as power factor. Now how you will find this will be equal to cosine theta is equal to qaida over water. Qaida over water. Now, if you want water, yes. So if you know total power, if you know total T, you can calculate the power factor of the supply also and of the load also. Supply as well as the load. This is for the generator as well as for the loads. Now, if I give you one example and then I will finish the just 5 minutes. I think you will solve it by yourself, but I will just give you the guideline. For example, there is a system with the generator, resistance, and there is resistance with the generator like this. Yes, this is 6 ohms and this is 8 ohms. 6 and 8, and this is 3 and this is 4. Yeah. Now the question is here, you supply certain voltage to these loads. Now the voltage is R. There is 200 angle 0. Angle 0. And here there is 200 angle minus 120. And here the third one. Here it is. This is this one. Huh? And here it is 200 angle 120. Yes. Yes, how you will do?
What is the resistance value there? On the right?
Yeah, in the right, all are this given. Here it is 6 minus 8j, 6 minus 8j, 6 minus 8j.
You're saying balance.
Yes, here it is 3, 4 plus 4j, 3 plus 4j, and 3 plus 4j, balanced.
Yes.
How you will handle this?
We know the line voltage, same the line.
Yes.
This we have the same.
If I ask you, there is a complex equation numbers over there, complex numbers, yes, in this. If I ask you how much is P total? There are 2 methods, Yasin. 2 methods. One is when you convert from this, either convert from delta to Y or Y to delta and calculate the equivalent circuits. Number 1 method. Yes, one load. Because here it is 2 loads connected, one in Y, one in delta. So it is up to you. You can convert this Y into delta parallel and then equivalent circuit and calculate the total power PT, QT and ST. Yes. The second thing is if I ask you P, so you can calculate P in delta separately and P in Y separately. Yes. How you will find P in delta? You have to find 3 times I square R. Why? Because here you have to find this power loss, because reactance will not give you any P. It will only consume in R. Yes? Only consumed in R. So the current over here, square multiplied by R multiplied by 3, this plus this plus this. This is one method. Yes? Similarly, if you want to calculate the power in Y, so it will be equal to 3 times I square R in Y, current in Y. So which current? Current flowing over here. Current flowing over here. Current flowing over here. This is the second method. Yes?
Yes.
Now, whatever you feel easy, you can do. Either convert this to delta or convert delta to y, and then calculate the equivalent complex numbers and I square r. You can find, up to you. Yes? Similarly, if I ask you Q, so what I will do, Q is consumed only in reactances. So for Q, in case of P delta, separate calculation. Y, separate calculation. And then add them together, it will give you Q. Q. Understand what I am saying or no?
Yes.
S, how you will find? If you know P, if you know Q, just add them complex number, you will get S. P plus JQ will give you S. R, you can calculate it is by voltage and currents also, but that will be long process. If you know P, if you know Q, you can calculate S. Power factor also you can easily calculate using this equation. Power factor equation. Clear, Walila? Yes. It's the same. Add them together. Because here, this is one mobile and another mobile you connect in parallel. This bulb is connected over here, parallel, not series. So you have to add this separate current. Power is coming in one load, power is coming in another load. This power plus this power, it will be added always. If it is parallel or if it is series, it will be always added because it is consumed. Anything else? So there will be a... Which one, sorry?
This one, the middle and at the end we add the sum.
Yeah, this total power, P total, it will be equal to Py plus P delta. Similarly Q, similarly S. Okay.
Yeah, I think that's all, doctor.
Yeah, that's from my side it's over. From your side, if there is any question, I'm ready.
That's clear.
Clear?
Clear. Yes.
Okay, Dr. Yasin, we have a simple gift for you.
Yes, yes,
And
yes.
thank you for your time and for your everything.
No, thank you very much for. No, this is no need because you are our students and
No, even
no
though.
problem.